Today we are going to see about self-control and vector control of PMSM. As the rotor speed changes, the armature supply frequency also changes proportionally so that the armature field always moves at the same speed as the rotor. The armature and rotor field move in synchronism for all operating points. Here, accurate tracking of speed of frequencies realized with help of rotor position sensor. When the rotor makes certain predetermined angle with the axis of armature faces, the firing pulses to the converter feeding the motors also changes. The, switch, the switches are fired at a frequency proportional to the motor speed. Thus, the frequency of the voltage induced in the armature is proportional to the speed. The self-control ensures that all the operating points, the armature and the rotor fields move exactly at the same speed. The rotor angle is adjusted electronically, hence there is an additionally controlled parameters passing greater control of major behavior of changing the firing of semiconductor switching of an inverter. This is the diagram for self-control of PMSM motor. The torque angle is said to be electronically, hence the fundamental components of phase A needs its lights along the direct axis that rotates at a synchronous speed. The switches must be triggered by phase A currently component when the phi s b electrical degree behind the phase A axis. This is achieved by firing the switch when the direct axis delta plus b behind axis of the shown figure. At high power level, the most common power converter configuration is the current fed DC link converter. In the inner current and outer speed loop, the phase control thyristor can be supply side of the DC link has a current regulating loop and operating control source. The inverter gating signal are under the control of shaft position sensor giving a commutator less DC motor with armature current control method. Thyristor The thyristor of this inverter utilize load commutation because of generated EMF appearing at the armature. It ensures the over excitation of synchronous motor. Next one is vector control vector control of PMSM motor. Here, the electromagnetic torque is an electrical machine is developed due to the interaction of current carrying armature conductor with the air gap flux. Consider a two machine whose armature conductor currents and the air gap flux is shown in figure. Each and every armature conductor experiences a force which contributes the torque. The torque is contributed by various armature conductors of the same direction. Even though the magnitudes may vary, it observed that the steady state and dynamic performance of most arrangements are better. Consider the second case with the armature conductor current distribution and the air gap flux distribution are shown in figure. In case the angle between the axis of the air gap flux and armature MMF is different from 90 degree electrically. The schematic diagram of vector control. The reference value of ID and IQ transformed into reference value of current, namely IA and IB and ID. These currents are compared with actual currents. The error values actuate the triggering circuit, which is also influenced by the rotor position, sensor, and the speed. Thus, the vector control of field used motor is achieved. Thank you.